In this video, I am going to go over the grade 9 Math PAT Part A. Okay, so if you haven't seen Part 1, make sure you check it out before you finish watching the rest of this video. Now, in Part 1, I didn't get a chance to complete number 7, so let's go ahead and let's solve number 7 right now. Okay, let's take a look at number 7 here. So the first time you look at it, you might be tempted to use BEDMAS rules. However, we can't do that because we've got 1/4 of an x minus 3/4, 1/4 minus 3/4 x. Those two you can't combine. So what we're gonna need to do is to distribute that 4 to everything inside the bracket. Now, when we go ahead and do that, we are gonna get the following. So -4 over 4. Plus 12x over 4. Now remember, the reason it's going to be positive is because I'm taking a negative and I'm multiplying it by a negative. So that's going to give us positive 12x, and then I'm just going to rewrite the 4 that's hanging out at the end there. Now, one thing that I noticed is I want to simplify this as soon as I can. However, this whole number doesn't have a denominator of 4. So I'm going to first convert it into a fraction by raising it to, by putting a 1 under it basically. And then I'm gonna go ahead and multiply both the top and the bottom by 4. So when I simplify that, that's gonna give me -4 over 4, which is our original fraction here. So I'm just recopying everything from the top. And then with our new whole number that's turned into a fraction, that's just gonna be 16 over 4. Okay, so what I can do with these numbers, I actually can now start to simplify them because they're all divisible by 4. So that's gonna give me 2x is equal to -1 plus 3x plus 4. Now I've got one negative and positive 4, that's gonna combine together. I've got more positive on that side. So that's gonna give me 2x. Again, I'm just recopying that 2x plus 3 plus 3x. So 2x is equal to 3 plus 3x. Now what I'm gonna do is minus 3x from both sides. And the reason I'm gonna do that is because by adding 3x to both sides, this portion here is going to cancel, but of course what I do to one side, I have to do to the other side. So that's gonna give me -x is equal to 3. Now, our answer we probably want, based on the question here, we want x to be positive. So what that means is I can flip my negative side. Really, you're dividing by 1, but if you don't get that now, that's okay. I can flip my negative to the other side to make it positive. So that's going to be x equals -3. So our answer is going to be -3. Okay, question 9. So what we're gonna need to do with this one is follow the rules of BEDMAS. So what I'm gonna do is write that up here. So the first thing we need to look at is evaluating our brackets. Now inside our brackets, we do have the operation of addition and multiplication. So we're going to need to multiply everything first. So I'm gonna write out everything. So 2 plus 2 times 5, well, that's gonna give me 10. And everything is still raised to the exponent of 2. Rewrite everything on the bottom. And then now I can combine everything in the brackets at the top. So 2 plus 10 is gonna give me 12 squared over 4 times 5, which is gonna give me 20. Simplify that further. Okay, so now we have to think, okay, well, what's 12 times 12? If you haven't seen it already, here's a link to my list of perfect squares. Make sure you know this before going into your exam. So 12 times 12 will give us 144 over 40. Now, we do need our answer expressed in a decimal, so there's 2 ways you can do this. You can go ahead and use long division. Now, I'm actually gonna do it a little bit differently. Instead of using long division, what I'm gonna do is simplify this fraction first. So I recognize that both of them are divisible by 4. So that's gonna give me 36 over 10. Now, when we think about fractions, there's a little rule here where when something is underneath the denominator of 10, we can actually move the decimal place value and put it in the 10th spot. So that means we can imagine 36 is our number, and we have our decimal kind of hanging out at the end there. Now we can move it to the 10th spot. So that's gonna go in there, turning this into a decimal, which will give us 3.6. Okay, and then that's gonna be our answer. Now, like I said, if that doesn't work for you, you can go ahead and use long division. Okay, number 10. So we've got to do a couple of things with this one. So we've got rational numbers that we need to organize from smallest to biggest. They've bolded that. Make sure you underline it or highlight it on that exam so you don't forget, right? Because they might switch it on you. So we do have to use a little bit of a code here. So 1 is going to represent our smallest number and 4 is going to represent our largest number. So what we want to do with this is probably convert it all to decimals. And the reason I'm saying that is because these two are going to be decimals that, I mean, it's up to you. You can convert it either way. I'm gonna stick to decimals. If you wanna convert it to fractions, you can do that too. But let's take a look at this. So the first thing is I've got the square root of 9 over 25. So again, if you take a peek at the square root chart there, we can see the square root of 9 is going to give us 3, and the square root of 25 is gonna give us 5. Okay, so I'm gonna leave that for right now and we'll convert it to a fraction in just a minute. Now the other one I have is 3 over 4. So 3 over 4, I'm thinking of 3/4, right? So that's gonna give me 0.75. Okay, now with this one here, we've got 0.7, but it's squared. So now I'm thinking, okay, I've got multiplication. Is there an easier way I can do this instead of working through multiplications of decimals? Yes, there is. So again, if we look at our perfect squares, 7 times 7 gives us 49. So 0.7, we're just moving that decimal place 1 over, will give us 0.49. So that one's kind of nice. Now 0.75, this last one here, has that little hat over it. So I like to think of that hat as like taming really messy hair. And so if we're thinking of a decimal, well, how's a decimal gonna get messy? It's gonna get messy when it's 0.75555, and you get the idea there. So that actually makes that decimal, because it does have those 5s that are repeating, it does make that decimal a little bit bigger than this one, okay? Because it's got those extra 5s there. It's got a little extra something to it. So that means this decimal here is definitely going to be bigger than this one here. Now let's go back to our first number here, 3 over 5. So what I'm going to do is turn that into a fraction over 10, just like we did in the previous question. So that I'm going to double everything. And by doubling everything, that's going to turn my denominator to something over 10. So that's going to give me 6 over 10. Well, that's nice. I can put that in the 10th place value, giving me an answer of 0.6. So now my fractions are 0.6, 0.75, 0.49, and of course our 0.75 repeating. So now we just got to organize them. So my smallest fraction is going to be the 0.49. My second smallest fraction, or the next one in order, is going to be 0.6. So that's going to get a 2 there. And then, like I said, the difference between these two, it's going to be that repeating decimal is our biggest, meaning this one's going to be our second biggest, and then this one's going to be our largest. So that is our answer for that one. Okay, on to number 11. So with number 11, again, I'm going to go ahead and check that list of perfect squares. So we can first of all just evaluate the square root of each of these. And so like I said, you do want to make sure you have this memorized because you're not going to have a calculator to punch this into. So the square root of 100 is going to give me 10. Square root of 25 is going to give me 5. And one thing I forgot to mention is when the square root is over both numbers of the fraction, so both the denominator and the numerator, both of those numbers are going to be square rooted. And then I'm going to do the same thing with the other part of the number of the question there. So that's going to give me 6 over 3. So now we're adding fractions. I think for this one, what I'll do is I'll use the butterfly method. So we're going to go ahead and multiply across. Well, 5 times 6, that's going to give me 30. And then we got to multiply across the other direction. 10 times 3, that's also going to give me 30. Those are nice numbers. And so, sorry, the reason it's called the butterfly method is because that kind of gives the impression of butterfly wings. So we'll have to add those two numbers of 30, and then we just need to multiply these two numbers at the bottom, which will give me 15. So if I add this up, that's going to give me 60 over 15. So now I have to think, okay, how many times can 60 go into 15? That's going to give me 4. And look at that. Our question says to record the integer. So our integer for this question is just going to be 4. Okay, number 12. So we've got inequalities here. Now I want to be super clear about the inequalities. Just as a reminder, when we are dividing an inequality by a negative number, we need to flip the sign. Okay, so I'm going to say it once more. When we divide an inequality by a negative number, we need to flip the sign. Okay, and that negative number could also be -1, just to keep that clear. So let's go ahead and let's look at this. What's tricky about this question is the way you need to record the answer. Now remember what I said at the beginning of our first video, if you record the answer incorrectly, it is gonna mark it wrong. So we gotta be super careful of this one. So first thing I noticed is we've got symbols that we're going to need to keep track of recording. So with these symbols, each number represents a symbol, an inequality symbol, right? So that's the first thing I'm gonna notice. The second thing I'm noticing is we need to, of course, record our value. So that'll be the answer to the question that we get when we solve this. So we've got -3x plus 7 is greater than -17. So what I want to do is get x's on one side and my numbers on the other side. The way I'm going to do this is move this 7 to this side here. Now I can't just pick it up and move it, so I have to add -7 to both sides, right? So if I add a -7 here, well, that's +7 plus -7, that's going to give us 0. But what I do to one side, I have to do to the other side. So now I'm going to rewrite everything. -3x is greater than -17 and -7. So picture algebra tiles if you wish. I'm thinking of 17 red tiles and 7 red tiles. Nothing is going to cancel out. They are going to combine together to give me -24. Okay, so now we have to get x alone. X is being multiplied by -3. So I have to do the opposite, which is to divide by -3. So divide by -3, divide by -3. Oh, we're dividing by a negative number, right? So remember, that means we're going to need to flip our sign. So that's going to give me x, and our symbol is going to go this way, is equal to 3. And so the reason it's going to be 3 is because -24 divided by -6. Oh, sorry, I don't think it's 3. It's 8, excuse me. It's going to give us +8 because a negative divided by a negative is positive. So now let's take a look and see what that's going to be like when we put it in the Scantron. Okay, so let's take a look at this. So we need to put in the correct symbol. So the symbol is going to go this way. So the alligator is going to be eating the 8. If you remember that from elementary, that means our symbol is going to go this way. And our answer was 8. So that means I need to record symbol number 3. Okay, so on my list, I'm going to record symbol number 3. So bubble that in, 3, and then the number 8. Bubble in the number 8. And of course, we're going to write it in there. And that's how you're going to fill that one in. All right, so let's take a look at number 13 here. So with number 13, what they're asking us to do is to evaluate x equals -3. So we are dealing with negative numbers. So again, I'm just going to show you that like rules for integers. But what we're going to need to do is plug in -3 anywhere we see an x. So again, let's go ahead and rewrite everything. So our normal bracket is what I'm drawing there. What I'm going to do is, because we're dealing with a negative integer, I'm also going to surround the -3 by brackets. So just picture that bracket as like giving it a hug. It's just keeping that negative sign really close to the number. So in the case of this x here, I'm going to pop in a -3 plus 8 over 10 plus our -3 here, which is just this x here that I'm putting in the -3. All right, so now we got to evaluate it. So what that means is they really just want everything to be one number. So first thing I notice is I've got -3 and +8. So I have 8 positive things and 3 negative things. So that means I have more positive things. So the number up there is going to be positive. So that's going to give me 5/10 plus -3. And that -3 right here is just coming from the original question. So now what I need to do is I'm looking at it and I've got fractions with this. So I can't just combine them. I'm going to go ahead and add my fractions there. So what that's going to give me is, for this one, I think I'll use the common denominator. So I'm going to need to multiply everything by 10. And by multiplying it by 10, that's going to make our numerator to be -30, because a negative times a positive is a negative, and our denominator, the number downstairs, is going to be 30. So that's going to give us this right here. So 5 plus -30/10. Sorry, I'm gonna write it up here. So I've got -5 plus +5, so I've got more negatives. That means my answer is gonna be -25/10. Now remember, if that was a little tricky, what I said with those integers, you have all the space and you've got all, like you can write all over your test. So if you need to draw the algebra tiles, go ahead and cancel your positives and negatives out. But I've got -25/10. Oh, it's over 10. It's my favorite kind of number there to turn into a decimal, because that's what we got to do here. So it's 2.5/10. I'm going to move that decimal 1 over, giving me -2.5. So that is our answer. Okay, so let's take a look at question 14. If you haven't already, what I would suggest for this one is to pop open that list if you don't have those perfect squares memorized, because what we have to do with this one is we need to list how many whole numbers are between 39 and 160 that are perfect squares. So what I'm actually just gonna do is list them out. So I'm looking at the answers of those squares, so that's gonna give me 49, 64, 81, 100, 121, and 144. If I go any bigger than that, I'm gonna hit bigger than 160. And if you didn't know that, you can just multiply 13 times 13 and see what you get for that one. So that means altogether, let's count how many of these are going to be there. 1, 2, perfect. So we've got 6 whole numbers, our perfect squares between 39 and 160. So all we need to do is to write our answer of 6. Okay, number 15. So what is a little tricky about this is they're asking you about integer rules, but a lot of students, when they see these brackets, their mind kind of goes to BEDMAS. So remember what I said in that previous question, those brackets are just giving that negative integer a hug. So what we need to do is really just go from left to right with this one. So our first part that we can combine is -13 and +7. So like I said before, if that isn't easy for you to do at the moment, like if you can't easily do that in your head, that's okay. Just draw out. In fact, you know what? Let's do it for this one. We're gonna draw out -13 tiles. And then we're gonna add +7 to that. So what's gonna happen, of course, is the positive and negative are going to cancel. And what am I left with? Well, I'm left with 1, 2, 3, 4, 5, 6, and that's gonna be negative. So by combining these two here, what that gives me is -13 plus +7 gives me -6. So now I'm just gonna keep going into, just keep going left to right. So from that, I'm going to need to subtract -2. Now, if we look at the rules on my integer sheet, what it says is we can add the integers by flipping the sign of the second integer. So -6 plus +2. Okay, I've got -6 things. So I've got more negatives and I'm adding positive 2 to that. So some of those are gonna cancel. That's gonna give me -4. So that takes care of this one. Cross out those ones too. So now we've got -4 and we're gonna add -6. Okay, well in my mind I'm picturing 4 kind of red tiles, 6 red tiles, we're just combining them. That's gonna leave me with our final answer of -10. So let's go back and let's look at what the question says though, because -10 is not our answer. The question's asking, when I combine all of this and I add another integer, I get 0. Okay, so that means I need to do something with that -10. So it means -10 plus an unknown number will equal 0. Okay, well, the only way I can get a 0 there is if I add +10. -10 plus +10, and that's gonna give us 0, meaning our integer that we need to record here is just going to be 10. All right, let's go ahead and let's look at number 16. We just have a couple more to go and then we're all done. So I'm looking at this and we are looking at the square root of 90. So they wanna know on the number line, what's the best point that's gonna represent that. So the first thing I'm gonna do is think about my list of my square roots and think about where 90 is gonna be, where 90 is going to fit amongst those perfect squares. So what's gonna happen is the closest I can get is the square root of 81 and the square root of 100. Now, when I actually take those square roots, that's gonna give me 9 and 10. So looking at our number line, we actually can cross off anything that is before the number 9 and after the number 10. So they didn't give us anything, any points that are after 10, but they did give us a couple that are before 9, so we can cross those off. Now, if I were to do my best guess to estimate these points, I would say this is probably about 9.1 or 9.2. This one to me, like 0.5, looks like it's right in the middle. So I'm gonna say that's roughly about 9.5. And this one is super close to 10. So probably about 9.8, maybe 9.9. Let's go 9.9. So now what I can do is I can actually multiply these numbers by each other and see which one is gonna give me close to 90. So 9.1 times 9.1 will give me about 82.81. 9.5 times 9.5. That one's nice. That one's gonna give me 90.25. It's not perfect, but it's pretty close. And sorry, I think I made a mistake here. Let me write that one at the top there. 9.9 times 9.9. That one's gonna give me 98. So the closest I can really get to this is gonna be this middle point here, about 0.5. So it might be 9.4, it might be 9.432 or something like that, but that's my closest point. So the answer to this question will be 0.5. Okay, number 17. So I'm looking at everything. There's no X's, which means we probably can just evaluate. Now, when we evaluate something like this, we are gonna evaluate using our BEDMAS rules. So let me write that out there. So we have to evaluate everything inside the bracket first. So 6 divided by 2 minus 3, 2 minus 3, not 3 minus 2. That's gonna leave us with -1. And again, if I'm unsure of that, make sure you draw the algebra tiles. So that's gonna give us -1 to the exponent of 3. Now, when we have negative integers and we have it to the exponent of an odd number, there's something interesting that happens. So I'm gonna show you, I'm gonna explain it 2 ways. The first way is there is a rule in exponents where when our exponent is even and the number inside the brackets or the base is negative and it's hugged by brackets, if that exponent is even, the answer is going to be positive. The opposite is true. If the exponent is negative, or excuse me, if the exponent is odd, then the answer is going to be negative. But let me show you why that works. So remember in the first video, I said exponent is like screenshotting or making copies or multiplying the number. So when I expand this all out, I'm going to get 6 divided by -1 times -1, and of course times -1. So you've got 3 -1s that really come from that exponent there. So we're taking a negative times a negative. Well, that's going to make a positive. So that's going to give me positive 1 here. And then we're multiplying that by negative 1. So positive times a negative. Well, that's going to give me a negative. So this is going to simplify to 6 divided by negative 1. All right, well, 6 divided by 1 will always just be the number 6. But because it's a positive 6 divided by a negative, that final answer will give me negative 6. Okay, question 18. So we need to figure out the closest whole numbers that are closest to this number here, the square root of 121 over the square root of 9. So first thing I'm going to do is just go ahead and evaluate that square root. That's going to give me with 11, that's going to leave me with 11 over 3. Okay, so what that means is over here, that point is 11 over 3. Now, depending on how you are with fractions or decimals, you're like, okay, well, how's that helpful? So remember, we're looking for whole numbers. So one of the things that I can do is to convert 11 over 3 into a mixed fraction. By converting it into a mixed fraction, I'm actually going to see where it falls on with regards to whole numbers. So how do I do that? Well, I have to look at how many times can I go 11, how many times can I divide 11 into 3? So how can I do that? The first thing I'm going to say is, what is the answer to 11 divided by 3? So remember what I said in our first video, that fraction division sign, or that fraction bar is really a division number. So the closest I can get, 11 divided by 3, the closest I can get would be 3 with a remainder of 2. Okay, and if I wasn't sure about that, what I suggest you do is definitely draw out 11 tiles, put them into 3 groups, and then see what happens. So as a fraction, what that's going to look like is 3 over 3. So our denominator is going to stay the same. We have 3 wholes and our remainder of 2. Okay, so how does this help me? The first thing I know right away is it means this number most likely is going to be 3. Because 3, let me write this out over here, because this number really is saying 3 wholes and 2/3. Okay, that's the first thing that's telling me. The second thing it's telling me is that this whole number must be 4, because it has to go in increments on that number line. That means my answer to this question is going to be 3 and 4. Okay, number 19. So one thing I do want to say is, again, if you need those algebra tiles, just go ahead and draw them on the side of your paper. But let's go ahead and solve this. So what we need to do is figure out our value for x. So we're saying x divided by 3, or a number over 3, plus 7 equals negative 2. So the first thing I want to do is get x's on one side, numbers on the other side. The way I'm going to do that is I'm going to add negative 7 to both sides. What that's going to do is cancel that out, right? It's going to go to 0. So I'm going to rewrite everything. And I have negative 2 on the right, and I'm adding negative 7 to it. So nothing's going to cancel out. I'm just adding 2 more negative tiles to negative 7. That's going to give me negative 9. So there are 2 ways you can, negative 9, not 3. So there are 2 ways you can solve this, and it all depends on what works for you. So I'm going to show you both. The first way we can do it is x divided by 3 is equal to negative 9. Then what we're doing to get rid of it is we got to do opposite operations. We got to multiply 3 to both sides, or I can recognize that something divided by 3 gives me 9. I have a pretty good idea of what that's going to be. So x is equal to negative 27. And again, the reason it's negative is because we are multiplying a negative by a positive. That answer is going to be negative. Okay, if that's one way. The other way I can do this is recognizing, again, that this is opposite operations. So when you see a number and it's over that fraction bar like that, you actually can just think about it like this. We can multiply those 2 numbers to get x alone, which is kind of what we did on the other side there. And that's going to go x times negative 3, or excuse me, 3 times negative 9, and that will give me x equals negative 27. So regardless, the answer is the same at negative 27. All right, everyone, last question. Congratulations if you made it this far. Let's take a look at this question here. We're looking at exponents, so it kind of takes us back to the beginning of looking at those exponent laws. So one thing I can recognize with these exponent laws right away in the first bracket, is the bases are the same. So that means I can combine those exponents together. So that's gonna give me 3 to the power of 7. And if you're not sure why that works, I'm gonna go ahead and explain it right now. So 3 to the power of 4, remember we're just gonna repeat that 3, the base, the big number, 4 times. But we're also multiplying it with 3 to the power of 3, which means we're multiplying it with 3 more 3's. So if I were to go ahead and add those up together, 1, 2, 3, 4, 5, 6, 7. So I'm repeating 3 7 times, or I'm screenshotting it 7 times, meaning I'm gonna get 3 to the exponent of 7. So that takes care of that bracket. And then what we're doing with that is we're subtracting it to this one here. So we've got 3 to the power of 7. I'm just gonna write that the way it is. And then 3 to the power of 0. So again, what I said at our first video, anything to the power of 0 is going to be 1. So that really means we're saying 3 to the power of 7 times 1, which is just gonna give us what we always get, which is 3 to the power of 7. So when I'm looking at this now, I'm saying we have 3 to the power of 7, and we're gonna take away 3 to the power of 7. So those are the exact same numbers. 3 to the power of 7, take away 3 to the power of 7. That's no different than saying 1, take away 1. That means our answer to this question is going to be 0. Okay? And so don't let that throw you off, because a lot of the times when kids see the answer 0, they think they did something wrong. Double check your work. You're probably gonna be good. All right, that is it for me. Congratulations again if you made it this far. If you all need any help, you guys know what to do. I wish you good luck on the PAT coming up. If you're watching this on June 21st, 2023, then good luck tomorrow, okay? All right, I'll see you all in the next one. Bye, everybody.